Okay, today we're going to talk about integration by substitution. This is important when we have an integral that we want to evaluate, but it looks a little difficult and it can't be evaluated in what it looks like now. It's too complicated. We're going to simplify it by use substitution. So in this problem, we have the integral of 1 over the cube root of 1 plus 2x squared. We're integrating that from 0, our lower bound, to our upper bound of 13. Now, looking at this integral, I can't just apply any quick rule and do it. No simple steps I can use. So I have to use sub. And for this case, I'm going to have u equal to 1 plus 2x. Now, that's the inside term of the cube root function. When I do this, use substitution, I'm also going to take the derivative of u with respect to x. Now this derivative is equal to 2. Now I'm going to solve for dx. So I'm subbing in u for 1 plus 2x, and dx I'm going to find. dx is equal to du over 2. And like I said, the u is going to be substituted wherever you see 1 plus 2x, and the dx is going to be substituted by du over 2. We're going to talk about the lower bounds and upper bounds in a minute. But first, let's get to the cube root of u squared, because that looks a little difficult to apply. So we have the cube root of u squared on the bottom of in our denominator of our integral. Now the cube root, what it really means is you're taking the inside term and you're raising it to the 1/3 power. And from algebra, when you raise a power to a power, like this case, u squared raised to the 1/3 power, we're going to multiply the two powers. So 2 times 1/3 is u to the 2/3 power. Now that we have u in terms of just a power and got rid of the cube root function, we can evaluate the integral. Okay, now I'm going to do two things. I'm going to pull out the 1/2 out of the integral, since it's just a constant, there's no variable. And also, I'm going to flip u to the 2/3 from the bottom, from the denominator up to the numerator. Okay, when I do this, I get 1/2 u to the negative 2/3 power du. Okay, now let's talk about those integrals, or the boundaries. Before it was from 0 to 13. Now we want to change that. We have two options. We can either change the limits or change the u back to x in terms of x after we integrate. So let's just change the limits now. We said u is equal to 1 plus 2x. Now for the lower bound, we saw that we had a value of 0 and the upper bound was 13. So substituting the lower bound into finding our limits, we're going to get u is equal to 1 plus 2 times 0, which is 1. So our new lower bound is 1. For the upper bound, it's the same thing. Just plug in the upper bound, which gives us 27. 27 is our new upper bound. Okay? Now we have our new boundaries. The only thing left to do is to integrate. And by using the power rule, we get u to the negative 2/3 plus 1. I'm representing that by 3 over 3 over negative 2/3 plus 1 from 1 to 27. Okay, now we just have to apply the addition. Now this is u to the 1/3 over divided by 1/3. Now when you're dividing by the fraction, I'm going to get 3 u to the 1/3 to the 1/3 power from 1 to 27. And evaluating it, I'm going to get, well, I'm going to pull out the 3. From 1 to 27. Okay, so now we have to evaluate the integral from 1 to 27. Now, to the 1/3 power, like we knew before, is equal to the cube root. And I'm going to take the upper bound minus the lower bound. So 27 is our upper bound limit, minus cube root of 1, which is our lower bound limit. Now looking at our prime factors for 27, we see 3 times 9, 3 times 3. And that shows that it's a cube root of 3. So we have 3/2, 3, and the cube root of 1 is just 1. So we have 3/2 times 3 minus 1, which is 2. Now the 2's are going to cancel, and we are just left with our answer, 3. So the evaluation of this integral, doing all the steps by use substitution, we were able to solve it in an easier method than trying to apply the integral in its difficult state that it was in before. And we get an answer of 3.